Section 5.1 is graphing quadratic functions. In a quadratic function, the greatest exponent is 2. This is the standard form of a quadratic equation. F of x equals ax squared plus bx plus c. When you graph, the graph is called a parabola. And it looks something like this. It's a U shape. If a is positive, the graph is going up. If a is negative, the graph it will be going down. When the graph is going up, the vertex is a minimum. And if the graph is going down, the vertex is a maximum. The steps for sketching the graph of a parabola. Stop the recorder and copy all 6 steps down and make sure you go in order when you identify the things. We're going to take step 1 at a time and work the problem. Step 1 says to state whether the graph goes up or down and whether it's a minimum or a maximum. So, number 1, A is positive, so it is going up, which means it is a minimum. Step 2, state the vertex. To find the x value of the vertex, the formula is x equals negative b over 2a. b is negative 10, so that's negative a negative 10, which is positive 10, over 2 times a is 1, so 2 times 1 is 2, and 10 divided by 2 is 5. So the x value of the vertex is 5. To find the y value, we plug 5 in to this equation. So x squared, which is 5 squared, is 25, minus, or negative 10 times 5 is a negative 50, plus 16. So 25 minus 50 is a negative 25, plus 16 is a negative 9. So my vertex is 5, negative 9. Step 3, state the axis of symmetry. The axis of symmetry is a vertical line at the vertex. And the equation of axis of symmetry is always x equals the x value of the vertex. So x equals 5. Step 4 is the y-intercept. The y-intercept is always 0, c. So that's 0, 16. Now we'll need to find the corresponding point to that. So I'm going to stop for just a minute and I am going to graph I'm going to plot these points. Now to get 0, 16 point to plot, I'm going to have to count by 2's. So I'm going to go over 5, negative 9 and plot that point, but remember I'm counting by 2's. So I plotted the point 5, negative 9. Then I plotted the point 0, 16. You have to draw your axis of symmetry, which is a vertical line at the vertex. So it's a vertical line at 5. And usually it's a dotted line. I'm having a little bit of trouble with this just because I'm counting by 2's and my graph is very small. Okay, this is the best I could do with a vertical line. It's supposed to be dotted, but I can't draw a dotted line. Sorry. Oh, there. Okay, so the corresponding point is the exact same distance from the axis of symmetry. If you will look, the axis of symmetry it's supposed to be at the half mark, so it's 2.5 to the left, so I have to go 2.5 to the right. And that ordered pair is 10, 16. Number 5 is finding the x-intercepts. To find the x-intercept, I put the equation equal to 0, factor and solve, which we worked on in section 5.3. So I take the equation and put equal to 0. Make my two binomials. The last sign is positive, so that means they're both going to be negative. Factors of 16 that add up to get 10 are 2 and 8. So I put each one equal to 0. So x is equal to 2 and x is equal to 8. So that is the ordered pair 2, 0 and 8, 0. So plot those 2 points. Plot the 2 points and draw your curve. Now it's a little challenging doing this on the computer. It's not a really good curve. You have a better chance of doing it on your graph paper. Step 6 is state the domain and range. The domain is all real numbers or negative infinity to positive infinity. The range are all the values above the vertex, and it would be the y value of the vertex. So it is from negative 9, and negative 9 is included. So negative 9 to positive infinity. Okay, example B. We have to put each one, state that goes up, so it's a minimum. The vertex is x equals negative b over 2a. B is 2, so that's a negative 2 over 2 times 1 is 2. So the x value of the vertex is negative 1. To find the y value, we plug negative 1 in for x into this equation. So that's negative 1 squared is positive 1. 2 times a negative 1 is a negative 2 minus 3. That's negative 1 minus 3 is a negative 4. The axis of symmetry is what cuts it in half, which is a vertical line at negative 1. The y-intercept is 0, negative 3. So let's go ahead, stop right here, and plot the points that we have. Okay, I plotted negative 1, negative 4, 0, negative 3, and my axis of symmetry. So from the axis of symmetry, I have to find the corresponding point from 0, negative 3. So from the axis of symmetry, I went 1 to the right, so I go 1 to the left. They are the exact same distance. And that ordered pair is negative 2, negative 3. To find the x-intercept, I am going to put the equation equal to 0. Factor and solve. My signs are going to be different. I'm going to use 3 and 1. I don't have any choice but to use 3 and 1. So x is equal to negative 3. I did this in my head, but let me go ahead and show you. Take x plus 3 equal to 0, and x minus 1 is equal to 0. So x is equal to negative 3, and x is equal to 1. So that is the ordered pair, negative 3, 0, and 1, 0. Plot those points. The domain is all real numbers, or negative infinity to positive infinity. And the range are all the values that are above the vertex. So it's from negative 4 to positive infinity. 1C. Now you try to do 1C and then turn the laptop on and see if you get all of the answers that I did. Take a moment and look and see if you have everything that I have. Example 2A. I'm going to identify the first 3 things. To find the vertex is negative b over 2a, so that's negative 4 over 2, which is negative 2. Negative 2 squared is a positive 4, and 4 times a negative 2 is a negative 8 minus 3. So that's negative 4 minus 3 is a negative 7. The axis of symmetry is x equals negative 2. The y-intercept is 0, negative 3. Okay, let's plot these points and find the corresponding point to the y-intercept. The corresponding point is negative 4, negative 3. The y-intercept, so we're going to put the equation equal to 0 and see if I can factor. My signs are going to be different. Factors of 3 that subtract to get 4. Well, there are no factors of 3 that are going to subtract to get 4. So, we don't have an exact x-intercept. So what we're going to do is come up with just another random point. Now look at your 2 points, the y-intercept. We know that it's going to look something like this. So it's going to be to the left of this point or to the right of this point. What is to the right of this point? X would be 1. Or to the left of this ordered pair, x would be negative 5. So I would strongly recommend either putting 1 for x or negative 5. The easiest one is 1. So I'm going to put in 1 into the equation. So that's 1 squared is 1, plus 4 times 1 is 4, minus 3. So that's 5 minus 3 is 2. Plot that point and find the corresponding point to that. The corresponding point is negative 5, 2. So if you don't get an x-intercept, then you're just going to have to pick some point to plug in for x to find your extra points. You always need 5 points. Number 6, the domain is negative infinity to positive infinity. The range, oh, I forgot to make my curve. Is negative 2 to negative 7. Excuse me, I'm sorry. The range is negative 7 to infinity. Okay, this leads me to next thing. If you can't factor, it's not the fact that you don't have an x-intercept, it's the fact that it's not an exact number. It is a decimal. As you can see, it crosses the x-axis here and here. Now, on the left side, I don't have a very good curve. You can use your graphing calculator. So get your graphing calculator, plug into the equation and for y. So the very first equation on your calculator is y equals x squared plus 4x minus 3. Your second equation, put it equal to 0. So that's the equation y equals 0, which is the horizontal line at 0, which is your x-intercept. So what you're doing, the reason why you're putting that in a calculator is because you want to try to find where the y equals 0 equation intersects with the coordinate. So then you hit second function trace, hit number 5 where it says intersect, enter, and you want to hit your your left cursor to where it's close to the x-axis and your curve right here. Hit enter 3 times until it says intersection. And if you do, it says x is equal to 6.645751310. So that is the ordered pair. 0.6, we're going to estimate, just say 0.60. Which 0.60 is a little past a half, so it's about right here. Again, I don't have a great curve. Then to find the other side, you do it all over again. Hit second trace, 5, and this time you hit the cursor to on the other side of your graph to where the cursor is on this side. Hit enter 3 times to where it says intersection, and that's the point -4.60. And if you will see, that's about where it crosses. Okay, look at this equation. Y equals -x squared plus 3x plus 4. Now this is going down, which is going to be a maximum value. Let's find the vertex. Okay, the formula for the vertex again is -b over 2a. So that's -3 over 2 times a is a -1. So that's -3 over -2, which is a +3/2, or if you want to write it as 1.5. Now when I go to plug in +3/2 into this equation, I'm going to leave it as 3/2. Now that negative, a is negative, so you want to think of it as -1 times 3/2 squared. So that's 9/2, so that's -1 times 9/2, which makes it a -9 over 4. Plus 3 times 3/2 is 9 over 2, plus 4 over 1. I have to get a common denominator. Oh, wait a minute, I need a common denominator, 4. So you get 25 over 4, which is 6 1/4. You could also let your calculator do that and put it in your calculator too. Okay, so I'm going to erase all this stuff. The axis symmetry is x equals 1.5. Your y-intercept is 0, 4. Okay, I'm going to plot these points. Okay, I plotted 1.5 up 6 1/4. Labeled my axis symmetry. Now I need to plot the point 0, 4. Now from the axis symmetry I went 1.5 to the right, so I'm going to have to go 1.5 to the left. And that is the order pair 3, 4. Now I need to try to see if I can factor this trinomial. So that's -1x squared plus 3x plus 4 is equal to 0. Now remember, you cannot have a -1, so I'm going to have to factor out a -1, or a cannot be negative. So I'm going to factor out a -1 and get x squared minus 3x minus 4 is equal to 0. Put each one equal to 0. So x is equal to -1 and x is equal to 4. So I do have x-intercepts. -1, 0 and 4, 0. And this curve is going down. Oh, I'm off my graph, sorry. Not making a very good parabola. The domain, -infinity to +infinity. And the range, now it's the y values that are below. So that is 6 1/4 to -infinity.